Hi, this is Mrs. Homberg again. Let's continue with our modeled examples. Here we have what looks like a more complicated circuit. We're going to put our high voltage. We're going to mark our low voltage. And of course, this is all worth doing because it lets us see where we have our rises and drops. Any metal that touches each other is, of course, the same voltage. So now what happens? We've got another little color we need over there. We've run out of colors. Let's make this the scribble black color, okay? So now, with this in mind, we see that there are some places where we can consolidate. We see orange to yellow, and that means these are in parallel. So we would go and work on R4 and R5 and say they are in parallel. So R4 is in parallel with R5. This becomes the replacement that we're going to put in this position. We see other pieces that can be consolidated. R2 and R3, they are in series. So we're going to add those up, and we see that this number would replace those two resistors. But what's our last step? If we think about what would happen if we had R45 here replaced by a single resistor, we would have this resistor in series with this one. So let's get R456 calculated and written down and redrawn. Notice that our circuit now looks like a lot of the simpler circuits we've worked on before. This now is very clearly in parallel. This will then be in series with the replacement, and we will notice that we can get REQ for the entire circuit. Hello, this is now a continuation with consolidated circuits, and I'd like you to try one step by step with me. Here we have a circuit. If you notice, we have the voltage from the battery, a resistor, which then seems to have connections to these two, which then we group down here and go through R4. Why don't you try using your coloring method to fill in the voltage drops across this resistor? Pause the video and then return for the answer. Now that you're back, did you find that these are the voltage drops across your resistances? Were you able to see that because orange and green are the same color drops for each of those two resistors, that R2 is in parallel with R3? If that's the case, then you can go through and do the math and replace R23 with its own resistance. Why don't you now redraw the circuit, but replace this? Replace R23. Replace it with what it's really equal to in parallel. Pause the video and redraw. Were you able to redraw the circuit this way? Now that it's redrawn, you can see that this looks as if it's in series. Well, now that it's in series, we know we can just add up the resistances to get the overall resistance for the circuit. Can you please pause the video and redraw the circuit so that you know what it looks like with just one R equivalent? As you've redrawn the circuit, you might see that now this looks very basic and something that we can solve. We can now get R equivalent and our voltage and use it to get I total or I battery. We use Ohm's law. V battery equals I total times REQ. And we'll see that I total equals the voltage divided by REQ, which is 0.17 amperes. That's the current leaving here and then starts being distributed throughout the circuit.